The quiz problem for today concerned a 10 kilogram mass moving at 230 degrees from the positive x-axis at 20 meters per second, colliding with a 20 kilogram mass moving at 130 degrees to the positive x-axis at 12 meters per second. So we have the momentum of one object and the momentum of the other. Now, the momenta of these objects are clearly 200 and 240 kilogram meters per second in the directions of the velocities. So that's why we've labeled the momenta like this. When the objects collide, they'll maintain their same momentum. And one question is, if they stick together, what will be their velocity after collision? In order to analyze this, we find the x and y components of the two momenta. Now the first momentum, the 200 kilogram meters per second, recall, was at 230 degrees with the positive x-axis. If we multiply 200 kilogram meters per second by the cosine of 30 degrees, we get the x component of the momentum of the first object. And if we multiply this 200 kilogram meters per second by the sine of the 230 degree direction of motion, we get the y component. Similarly, we can get the x and y components of the second momentum by multiplying by the sine and cosine of the 130 degree angle. So we know what the x and y components of both momenta are. The x components add up, if you add these numbers up, you'll see they add up to negative 282 kilogram meters per second, and that these add up to 31 kilogram meters per second. So that the total momentum, okay, the x total is negative 282, the y total is 31, both kilogram meters per second. So that the total x momentum is represented by a vector with an x component of negative 282 kilogram meters per second and a y component of 31 kilogram meters per second. We can find the magnitude and angle of that total momentum by the very straightforward calculation that we should be used by now. That we should by now be used to using. Total momentum is the square root of the square of the x and the square of the y. I didn't even write that in, just indicating that we use the Pythagorean theorem. And in this case, we're going to get 284 kilogram meters per second. And the angle is going to be the inverse tangent of the y over the x momentum. The kilogram meters per second will divide out, so I didn't write it in here, but it's 31 over negative 282 plus 180 degrees. Now why the plus 180 degrees? Because the x component is negative. Remember, the inverse tangent is between negative 90 and positive 90 degrees. So that if the x component is negative, we're going to have to add 180 degrees to get us over into the third or fourth quadrant, which is of course where the x component will be negative. And we obtain then an angle of 174 degrees, which is not at all out of line with the way we've drawn this. It's just shy of 180. A large component here, a small one here. We're almost at 180, so the 174 degrees makes perfect sense.